In this video, we are focusing on ordering fractions. So using equivalent fractions, so fractions that may look different but actually have the same value, they equal the same. You can put fractions into ascending order, so that's smallest to biggest, so getting bigger, going up, or descending order, which is biggest to smallest, so going down, using the greater than or less than symbols. If the numerators are the same, which we can see they're both number 1, the smallest fraction is the one with the biggest denominator. So we have 7, which is actually a bigger number than 2. This is the smallest valued fraction, okay? So this one here is the smallest. That's why we say 1/7 is less than 1/2. So if the denominators are the same, so we both have the number 10 here, the smallest fraction is the one with the smallest numerator. So we can see here that 3 is smaller than 7. Therefore we say 3/10 is less than 7/10. To order fractions with different numerators and denominators, such as 2/3 and 3/5, we can use our knowledge of equivalent fractions to produce fractions with a common denominator and then compare them. So we're going to create 2 new fractions which have the same value but look different. So they will be equivalent fractions, but we're going to make them so we can compare them. So first of all, I'm going to look at the denominators, and I'm going to just multiply 3 times 5, and that gives me 15. I come back to the 3 and I think, what did I do to the 3 to get to 15? I multiplied it by 5. I look at this one, the number 5. What did I do to number 5 to get to number 15? I multiplied by 3. So now I've established that, I've got to do the same to the top numbers, the numerators. So I multiply by 5 and multiply by 3. 2 times 5 is 10. 3 times 3 is 9. Now I can compare these fractions because they have the same denominator. And I can see that the largest one is 10 over 15. So I can technically come back to my original fractions and say 2/3 is greater than 3/5. So you must come back to the original fractions. You don't make statements about the ones that you've made that are equivalent. You must come back to the original ones and write the answer with the correct symbol, which is greater than. If these fractions were around the other way, the symbol would be facing the other way, saying that 3/5 is less than 2/3. So, in order for you to have the greater than symbol in this situation, the fraction at the beginning must be bigger or greater in value than the second one. Mixed fractions must be converted to improper fractions before you can compare them. So I'm actually comparing a mixed fraction with an improper fraction. So this has not been converted, this is correct as a mixed fraction, and this is already started as an improper fraction. So I actually can't compare them until I change my mixed fraction to an improper fraction like this one here. So what I need to do is go 2 times 7 is 14, plus the 3 equals 17, and the denominator stays the same over 7. So now that is improper to that mixed fraction. I can then drop this one down here beside it. The same denominator enables me to compare these two now. I can see that 17 is greater than 16. So I can say 17 over 7 is greater than 16 over 7. But remember, you must come back to the original fractions and put the symbol in for greater or less than in. Do not leave it as 2 improper fractions. Okay? So we know that 2 and 3/7 is greater than 16 over 7. Sometimes you will be asked to compare more than 2 fractions and then write them in either ascending order, which is smallest to biggest going up, or descending order, which is biggest to smallest going down. We have three fractions here, all with different denominators, so it's very difficult to compare them. So we have to find the lowest common denominator of 3, 4 and 5, okay, as we've got here. So to do that, what we have to do is look at our times tables, and we go through our times tables to find answers that are going to equal the same. So if we go through our 3 times tables, we can find that 3 times 20 will equal 60. If you go through our 4 times tables, we know that 4 times 15 equals 60. And if we go through our 5 times tables, it is 5 times 12 that equals 60. So we've got a 60, a 60 and a 60, which are all common to these three denominators. So we're now going to recreate 3 fractions with the denominator of 60 so we can compare them. Okay, so now let's look at this one here. All right, so if we go 60 divided by 4 times 3, we get 45. I'll repeat that. We go 60 divided by 4 times 3. So we start from the bottom, take the big number we've just chosen for our common denominator, we divide it by the original denominator and times it by the numerator. Let's look at this one here. Okay, we have 60 divided by 5 times 4 and we get 48. Let's look at this one here. We have 60 divided by 3 times 2 and we get 40. So now we have 3 fractions with the same denominator and different numerators. So now we can actually place these in order, and I'm going to do it up on this side here. So we know that 40 is the smallest number, 45 is the next number, and the biggest number is 48. And now we can compare these, okay, in order and then bring them back into their original form. We never leave this expanded equivalent fraction, this much bigger fraction. We must come back to the original fractions because that's what they're asking us to do. So 40 over 60, this is 2/3. So 2/3 is the first one that we write down. We then look at 45 over 60. Well, 45 over 60 is 3/4. So 3/4 is the next one that comes in line. And lucky last is 4/5. 4/5 is the next one that comes in order. Okay, so now we've placed this in the correct order, ascending order. 2/3, 3/4, 4/5, smallest to biggest.